Every single car, truck, and bus out there on the road today is basically a rolling computer, and it's constantly generating a huge torrent of data. But what is it all actually saying? Well, in this explainer, we're going to decode that secret language to unlock the really powerful, cost-saving information that's hiding inside your fleet.
Because that's the real question, isn't it? I mean, this is about so much more than just tracking a dot on a map. This data, when you know how to read it, can pinpoint inefficiencies, it can predict failures, and it can directly impact your bottom line. So, let's get into it.
All right, here's our roadmap for today. First, we'll talk about the vehicle's secret language. Then, we'll dive into the two big data standards, OBD and J1939. After that, we'll learn how to read the data dictionary, see how all these messages get packaged up, and then figure out how to decode them. And finally, we'll bring it all home and talk about why this stuff really matters.
Okay, so let's start at the beginning. Just think of a vehicle's internal network as its central nervous system. What we're doing is tapping right into that system, which is constantly, 24/7, monitoring dozens of critical parameters.
Yeah, this goes way, way beyond simple GPS. We're talking about a rich, real-time stream of information. Questions like, how hard is the engine really working? What's the coolant temperature right now? Are there any hidden fault codes that are about to become a big problem? The vehicle knows all of this, and it's communicating it constantly.
But here's the thing, not all vehicles speak the same language. It turns out there are two dominant standards out there, and understanding the difference between them is absolutely key.
So on one side, you've got OBD2. This is the language of your personal car, your light-duty trucks. It's fantastic for basic diagnostics, and it's legally required for emissions control. It's the whole reason your check engine light comes on. But then on the other side, you have J1939. This is the professional-grade language for the big stuff, heavy-duty trucks, buses. It goes so far beyond the basics, giving you a much deeper, more detailed stream of operational data that's frankly essential for serious fleet management. So, for now, let's focus on J1939. To understand this language, we're going to need a dictionary, and that dictionary is something called the FMS PGN Guide, which is basically a big document that lists all the specific data words a truck can use. Now, the key term you're going to hear is PGN, which stands for Parameter Group Number. Don't let the name intimidate you. Seriously, just think of a PGN as a single word in the vehicle's language. It's just a unique code that stands for one specific piece of information. That's it.
For example, here are some PGNs all about fuel efficiency. You can see that PGN FE9 reports on total fuel used, and right below it, FEDC tracks total idle fuel used. Just stop and think about that for a second. If you had got data for every vehicle in your fleet, you'd know exactly where every single one of your fuel dollars is going.
But it's not just about fuel, not by a long shot. J1939 data is also critical for maintenance. PGN FEE, for instance, gives us the real-time engine coolant temperature, and FECA, that one alerts us to any active diagnostic trouble codes. This is the very foundation of predictive maintenance. It's about fixing those small problems before they become a massive headache on the side of the road. And finally, we get these incredible operational insights. We can see engine RPM, we can see the total distance a vehicle has traveled, and we can even see the total engine hours. This lets you service your vehicles based on actual usage, not just some arbitrary date on a calendar, which can dramatically extend the life of your assets.
Okay, so now we know the words, the PGNs, but how are they actually delivered? They don't just show up in a random jumble. They're neatly packaged into structured reports. Let's take a look at how that process works.
The whole process is actually pretty logical. First, an event triggers a report. Let's say a driver finishes their trip and turns off the ignition. That's the trigger. The telematics device in the vehicle immediately grabs all the relevant PGNs for that trip, bundles them up into a specific report format, and then zips it off to a server for analysis.
And of course, there are different records for different events. You might get a trip summary report when the ignition turns off, or maybe a periodic health report that's jam-packed with rich J1939 data, or even a diagnostic report that specifically looks for fault codes. Each one is a purpose-built package of information designed for a specific moment in time.
So we've got the words, we have the reports, but there's one final, crucial step. We have to translate the raw message from a language that's meant for machines into one that we can actually read and use.
To save bandwidth, all this data is sent in a really efficient compressed format. Now for computers, this raw machine code is perfect. It's exactly what they want. But to you and me, it just looks like a meaningless jumble of letters and numbers. It's basically gibberish. And here's what that looks like. Up top, you have the raw machine code, just a long, intimidating string of text. But with the right key, the reporting guide, it gets translated into the clear, human-readable data you see on the bottom. And suddenly, meaningful values like 145, 101, and 4620 just emerge from all that noise. The reporting guide is our decoder ring for this whole process. It's what tells our system exactly what each piece of data means and where to find it. For example, the guide knows that in this specific type of report, the 14th value is always the maximum vehicle speed. And it knows to take that raw hex value 91 and convert it into a clear number we can understand, like 145 kilometers per hour. And that, right there, is how we turn all that gibberish into actionable intelligence. Okay, we've gone pretty deep into the technical side of things, from PGNs to machine code. So now, let's pull back and connect all of this to what really counts, turning this data into real-world action. Because at the end of the day, this is probably the most important takeaway. The data itself, it's just a tool. The real power comes from the smarter, faster, and more profitable decisions that it allows you to make. So what can you actually do with all this? Well, you can slash fuel costs by finally getting a handle on idle time. You can prevent expensive breakdowns by acting on fault codes before they become critical failures. You can build a safer fleet by looking at real metrics like max speed and harsh braking. And you can manage your assets way more efficiently, servicing them based on actual engine hours instead of just a date on the calendar.
So we've taken this journey from what looked like a secret, cryptic code all the way to a clear, actionable language. Learning to speak vehicle isn't just a technical exercise, it's about unlocking a whole new level of intelligence for your entire operation.
And that kind of leaves us with a final thought. The amount of data that's available and the insights we can pull from it, it's only going to grow. This is the conversation our vehicles are having now. Can you imagine what they'll be able to tell us in the years to come?